model. Here we go. Our objective for today, I can solve and graph linear functions and equations. Let's read together. 1, 2, 3. One more time. 1, 2, 3. Thank you. So today we're going to do a quick, I'm going to do a quick review of what we've seen so far with linear functions and equations. And I hope the example that we use on the warm-up helped. And I'm going to continue doing some more of these things so that we can make sure we master this concept, linear functions and equations. So first of all, we don't need a Freire model, but let me recap of what I gave you on a Cornell note. Here it goes. Linear functions. I gave you guys a Cornell note that looked like this. Do you agree with that? Yes, and I gave you the whole printout with a definition and all that, and I had you write these examples down, right? So now check this out. According to the definition for linear functions, it says it's a relation that assigns exactly one output value for each input, and it's in two variables, and it also has a slope. The example given were these. Look up, please. Now that you understand functions, look at this relation here of coordinates or order pairs. Look at it. Tell your neighbor specifically why this is a function. All right, Armando, why? So the x -2 are identical, so are the y's with a -2. Hands if you agree with that? Yes, okay. So we know what they are, and we said here we have f of x equals 2x plus 1. But we said that f of x is the same thing as saying which variable? F of x is the same thing as which variable? Y. So we just write it in function notation. That's the only difference. Let me show you the definition of a linear equation. Look up, please. Linear equations are two variable equations where the highest degree is 1 on the variable, and they can be graphed to make a straight line. So in different words, but didn't we graph these and we get straight lines also? Okay, so just different definition, okay? However, I want you to focus on the examples. Look up, please. Here go the examples. Look at this is a function. Stop messing with the iPad. Stop writing anything and look up to the screen. These are examples for a function. You guys see them? Let me show you examples for linear equation. There they. Let me go back to functions. You're just focusing on the examples. Equation. Function. Equation. Function. Equation. Functions. Equations. Functions. Equations. All right. So, really quick, I'm going to send you a screen, and I want you to answer the questions. Questions are, linear functions versus linear equations. What's the difference between linear functions versus linear equations? Answer that on your screen, please. All right, so most of you agree, look up, most of you agree that the difference between linear functions and linear equations, the one obvious one, is that linear functions have f of x, that is correct, and linear equations do not. I agree with that. Also, some of you mentioned that linear functions have slope. Well, guess what? Linear equations do have slopes. The only thing on this definition, it's not written in there, but once we get to that part of the next lesson, you'll see that it's in there. However, the most obvious one is this one. Look up, please, to the screen. This one has all the straight lines represented. So follow me along. Here we go. Y equals 4. Everybody go like this. That's the line y equals 4. X equals 7. Everybody go like this. X equals 7. So y equals 4 is like this. X equals 7 is like this. Okay? How about the other ones that have y equals something x? Those are like this. Everybody go like this. Like this. Diagonal like this. Or like this. Or if you go like this. Go Power Rangers. No? Morphin Power? No, never mind. But everybody see, it includes all the equations, which means it has all the straight lines. Now let me show you the linear functions. What's missing? The vertical one. Does everybody see that? Why is it missing the vertical one? Because if we graph the vertical line here on the none example, there it is, and we test it from far away with your pencil. Overlap my red line. I'm going to go from left to right. I'm going to scan it like a Terminator. Does it touch that line at more than one point? Yes, it touches the whole line. Here, 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 here. That's why it's not a function. That's why it's not included over here. That one should be over here. So that means that what kind of graphs do we have here? They're straight lines, all straight lines, except which one? Except which one? Vertical. And for linear equations, it has what? All the straight lines. Horizontal, vertical, and Power Rangers, yes? Okay. All right. So with that said, we have steps. Let me go over this one. Writing utensils down, look up to the screen. Here it goes. I'm going to go over this one completely. You've been graphing these, but I still sense a disturbance in the force. So stop writing. Stop messing around with the iPad. Doesn't matter if it goes to sleep, the screen. I want you to pay attention to the screen up here. I'm going to do this one step by step. First step, we need to solve for y. Tell your neighbor what I just said. So, right now it's in standard form, isn't it? Yes, so I need to solve for y. I need to draw a line down, which means I need to leave y by itself, so I subtract 6x, so I end up with 3y equals negative 6x plus 18. Am I done? No. Divide by 3, divide by 3. So my new equation is y equals negative 6x divided by 3 is negative 2x. 18 divided by 3 is 6. Did I solve for y? Yes. Yeah, because y is by itself. I'm done. Step 2, we need to get an input-output table. X, y, and what is my domain? Negative 2, negative 1, 0, 1, 2. All right, are we there so far? To find the values of y for those, I need to start substituting values. My first one is negative 2. That substitutes in here instead of x. I write negative 2. So then I bring everything else down. Y equals negative 2 times negative 2 plus 6. Y equals 4 plus 6. Y equals 10. That goes right there. What's my next value? Negative 1. So then I go y equals negative 2 times negative 1 plus 6. Y equals 2 plus 6. Y equals 8. What's my next value? 0. So I write y equals negative 2 times 0 plus 6. Y equals 0 plus 6. Y equals 8. I'm sorry, 6. Sorry. I did that to see if you were paying attention. So now, what did I say last time? As long as you show me work for 3, and you find the pattern, you can write the last two in. Is that correct? What are my last two, Yair? 4 and 2. Hands if you see that. Okay? So let's see. Step 1, solve for y. Step 2, fill in your values, your input-output table. And step 3, let's graph this. Negative 210, negative 210, negative 18, 06, 14, 22. Graph your line, and the line needs to have arrows at the end. Does it have arrows at the end? Yes. Did it go through all those points? Yes. Therefore, I'm going to leave that one up there. On your screen, I'm going to give you a new one. Work that out on paper. Take a picture. Insert the work in the screen, and then graph it on the screen. Tell your neighbor what I just said. Okay? Ready? Go. All right? Lastly, before we leave, look up to the screen. I'm going to do a recap on vertical lines. Here it goes. And horizontal. So let me draw a horizontal line. Look up to the screen, please. I'm going to draw a horizontal line right there. Do you agree that's a horizontal line? Yes. Let me show you the equation. Look at the line. Look at the equation. Let me show you another horizontal line. Let me show you the equation. Let me show you another horizontal line. Tell your neighbor the equation, please. Everyone, y equals -7. That is correct. So, what's missing in this equation if it's a two-variable equation? The x. If it's missing, it's because there is no x. So what is the value of x if it's missing? 0. That is correct. Let me show you a horizontal line. I mean a vertical line. Here it goes. Tell your neighbor the equation of that line. X equals -2. Hands if you agree with that. That is correct. Let me show you one more. Tell your neighbor the equation of that one. X equals 9. What's missing on this equation? What variable? So y equals to what? 0. That is correct. Okay? Lastly, from now on, whenever I'm asking you to write different forms of equations, check this out. We already know y form. It's y equals 3. Does that look familiar? Yes. How about y equals 2 plus 3x? Does this look familiar? Yes. However, from now on, I want you to write the y form like this. Y equals 3x plus 2. Which one goes first? The variable and then the constant at the end. Do we know what a standard form equation looks like? ax plus by equals c. Or it could be written like this. C equals ax plus by. As long as the x and the y are on the same side of the equation. Everything sense? All right, so home plate for tonight is on pages 155, 157, and 159 only. Okay? Enjoy your home play. As soon as your iPad is put away, logged out, wait for the bell. There is tutoring today. If I don't see you guys tomorrow. Bye.